Hello everybody, welcome to the Python course. So we have started module 9, that is file handling and modules. We have covered the file handling part in our previous lecture. Now we'll be covering the modules part. So let's get started. I have already opened my Anaconda Navigator. Now I will be opening a new Jupyter notebook. Let's get started. Okay. So I go into documents, GitHub projects, Python trainings, tonic, and I will make a new Python notebook that is named as module 9 module. Okay. In this part, we will be seeing the math module, the random module, and OS module. Right? So let's get started. First of all, to work with any of the mathematical functions, we need to import the math module. Let's say we wanted to know the value of pi and we wanted to use it in our algorithms or in our equations. So we cannot directly write the value of pi, or we cannot remember it, right? For that we have a inbuilt module named math. We need to import it, and then we could use their inbuilt variables or methods to have that variable or have that value, right? For example, if we wanted to have the pi value, so we could import the math module, and then by using dot pi we could simply simply have its value. Similarly, for the exponent value, so we could have math.e, right? Then if we wanted to have the ceil and the floor functions, right? For example, ceil method takes the upper limit, right? So for example, if we put ceil 3.14, it will take 4, and if we take the floor, it will take the 3.0, that is the lower limit, right? Similarly, if we wanted to calculate any factorial, so that can be calculated by using the dot factorial method, and power is calculated by using the power method, right? Right. And if we wanted to do a square root, that can be also be done. So let's get into practice all these methods, right? First of all, what we need to do is we need to import this, and we are importing the math library of Python, right? So once it has been imported, now we could easily call the pi method or the pi variable, so we can get its value. Similarly, we can get the exponent value also by using dot e. Then we wanted to have the ceil function. In this part, we wanted to have the upper limit of this, right? Math dot floor, we get the lower limit of this. Similarly, if we wanted to write the square root of 34, or I can say 25, so we could get a square root also, right? And if we wanted to have the power, right? Power, I guess, takes two arguments, 2 raised to power 6, right? So this is our power argument, power function or power method, right? Then we have the factorial. we wanted to calculate the factorial of 120, then it comes out to like this. If we wanted to calculate the factorial 5, it is 120, right? So these are some of the inbuilt functions. We can import the math library and then we could use it, right? Also, we could also give the math module as a alias name. For example, we wanted to import math as m. So what does as m means? Instead of writing math.py, we could simply write math m.py. So m is not defined because we have not run. We need to run it again and then we'll run it. So it gives the similar result. So basically we wanted to get rid of math, and instead of typing math again and again, we wanted to have a short name notation. So likewise we could have a alias name. So this is basically a alias of math, and it represents small m, or you can say a short method, right? So this way we could write our functions. Then we have the log value also. For example, if we wanted to calculate the log x to the base, right? So this is logarithm of 100 to the base 10. That is how it is being calculated by using the log, right? And then we have the exponent, right? E raised to power x, right? So that is also be calculated, right? Then we have also have radians and degrees. If we wanted to convert this 90 into radians, so that is also done by using math.radians. And if we wanted to convert 1.5 into degrees, so this is how it is being converted. So radians basically converts angle x from degrees to radians, and degrees converts the vice versa, that is convert an angle x from radians to degrees, right? Okay. Okay, so this will quickly see all those functions. So for example, log of 100 to the base 10 we are calculating, so it comes out to be 2, right? Then we calculate the radians. So it does not have radian, it has radians, right? And then we calculate degrees, degree 22 radian, so it does not have any degrees it, right? Okay, so this is how your math module works, and we have imported a math module and given a alias name or a shorthand notation, right? So this is how you can call the inbuilt method, right, and then start working on it, right? So one thing now, at this point of time you might have any questions regarding your import statement. What does this import does it? So how is this math being imported to my this Jupyter notebook, right? So this we need to understand how does import works, right? So basically when you install your Python, or Python is being installed via Jupyter node via Anaconda, so what it does in your setup tools, right? So it gives you all the necessary inbuilt methods and inbuilt libraries that comes as a complete package along with Python, right? So if you wanted to install any additional package, then you need to go for your pip install, right, or conda install. So these are the two methods in which you can ask for additional package which is not provided by Python itself. You can ask from the internet and download that package in your Python setup tools, right? But the question arises how this import works. How does it tries to find out whether this math module is being present at your Python setup tools or not? So that works according to your sys path, right? So what does sys does? Sys.path does, it will first check whether your import, like whether your whatever library you are calling has been present in this library. Then it will check in your current folder. Then it will check in your Python. Then it will check in the lib folder of Python. Then it will check for dny load, right? Then it will check for your side packages, right? So basically it will iterate through all the directory structure of Python as well as your current folder structure and try to find out that particular module, right? If the math named .py file exists in your folder, then it will fetch and give you that folder, and it will not look for the side packages, but your actual math module is present at your side packages, right? So it will be a contradictory, and it will always give you this math module which is present in your own directory. So now one thing to remember and one thing to keep in mind, that don't name your file names with the names of the inbuilt functions or inbuilt libraries, right? If you try to do that, so there might be a conflict and you might end up getting that library not giving you the accurate results, right? So let us try to see, try to import then we need to check what does it system dot path does, right? So I'm trying to do system, then print sys dot path, right? So what it will does is it will check any imports in this current folder. This is my current directory, right? Then it will check for the anaconda, that anaconda is being, python has been installed inside your anaconda library. It will check there whether this package has been listed there or not. Then it will check for lib folder, under lib folder, then it will check for local lib, then it will check for side packages. If it finds in side packages, then it is okay, otherwise it will go further. Okay, so the important thing to remember is don't try to name your files by the name of any packages. If you try to do that, it will give you an error and it will try to find that package, because this package is basically a Python file only, which consists of some of the uh, some functions and member variables, right? So you need to be a little bit cautious while defining your file names, right? Okay, then okay, then the next module is random module. For example, so this is a random module and we are trying to import that random module. This is also an inbuilt module, right? And this random int, what it does is it will try to give you a random value between 12 and 100. You specify a start and you specify end, that including start and end. It will give you a any random number between these two intervals. And if you specify random, so it will give you a random number, right? That is a floating point value, right? And we have a random.choice also, in which if there are some categorical variables or categorical values and you wanted to randomly choose one, so that can be used by using random.choice, right? So let's see this in practice, right? Import random, right? Uh, random, sorry, my bad, random dot randint, then I specify the value between 12 and 100, so it will give me a random value. If I try to run again, it has given me a random value again, right? Again it will try to give me a random value, right? Similarly, there is another method called random, right? It will give me a random floating point value, right? Then we have random.choice, in which there are names of cities: Noida, Delhi or Bombay, right? So it has given any random value. Now it has given Noida, now again it has given Delhi, right? Again it has given Delhi, again Bombay, right? So this is how it works, right? Okay. So the next module that we're gonna study is your OS module. So this is basically a very important module in terms of when you are working with your files and paths and your directories, right? So let us try to understand what are the methods and functions of the OS module and how we can work upon it, right? Okay. So let us try to understand the functionality and the description of these methods, right? The underlying structure is same. So first you need to import the OS module. So OS module gets imported. So then your dot, and then there are some methods which are listed down, right? Okay. So let us try to understand first method, that is os.rename. For example, it renames the file or directory source to destination. There is a file. Okay, so we have also built a similar file name, right? In the previous lecture we wanted to rename that file, so that could be done by using your rename method, right? Then the next is your os.remove, right? Now os.remove will only remove a specified file. I am again repeating it, specified file which you specify here in the path. It does not remove the directory. So path is a directory, it will give you an OS error, right? Only the file is removed, right? Okay. Then the next module is os.make directory. It creates a new directory. And remove os.remove directory, it deletes the directory, but it will only delete that directory when the directory is empty. If it contains some of the elements inside that directory, it will not be removed, right? So these are some of the methods we will see one by one. Okay. Then will have list directory. It will list all the names of the entries in the directory given by your path. Okay. Then we can change the directory, current working directory, by using chdir. Okay. Then get current working directory, we wanted to know in which directory structure I am, that we gonna see by using os dot get cwd, right? Then os.stat performs the equivalent stat system on the given path, right? Then we have the os.symbolic link, right? It creates a symbolic link pointing to the source named link. So it is only visible, it is only present in your Unix based system, right? So let us try to see these functions one by one. First we have imported our OS directory. Then we wanted to see in which current directory I am working. So that can be seen by using your os.get current working directory. Let's see, right? So I have already imported my OS. Then I see, so print import OS, then os dot, oh sorry, get current working directory, right? Okay, so now I am in this folder, users, Ashish Bansal, documents, GitHub projects, Python trainings and tuning, right? So this gives me the current directory which I am working on, right? Okay, then we need to make a new directory, right? Or we need to change our directory. So that could be done by using os.makedir, right? And this os.path.join, so what we are trying to do is we are trying to join this path in our current directory. So we are making this foo as our directory. So likewise you can see that here I am in the users, pawan, pycharm project, skill group programs, and then afterwards I have created a new directory named foo. So this path I have joined it, right, by using your make directory. Then I am also changing that directory to my this foo, right? So let us try to make a new directory, right? First of all, what I will do is I will current dir os dot get cwd, right? Then what I will do is os dot make dir, os dot path dot join, right? I'm trying to join my current dir with a new directory, right? So let's call it as new, right? Okay, right? So when I run it, and then os dot list dir, right? Okay, so now I'll explain again one by one. First, we have imported the OS directory, OS module. Then we are trying to fetch the contents, like get current working directory. So what this says, in which current directory I am in currently. So currently I am in users Ashish Bansal, document, GitHub projects, Python training and pruning, right? Then what we have done is we have set this current path to our current directory, right? Then by this command we are joining the current directory with our new, right? And so let us try to print this. So what it does, okay, so now you can see that, so this was my current directory and I have concatenated current directory with new. So this is my new, right? So this path, and then I have make a new directory by the name of new. In the os.list directory you can see this new gets created, right? So this new gets created, right? Okay. So to list all the files in your current working directory, you can do it by using your list dir. So it returns a list containing the names of the entry in the directory given by your path, right? Okay. So the next is your os.path common name path manipulators. So we have split text, we have join, right? Okay. So in this split, what we do is, so this is your current path and we wanted to split it by using your file name and your directory name. So home users pictures is your directory and foo.jpg is your file name, right? So we wanted to split it. We wanted to make sure your path, your current folder or your parent folder gets separated from your file. So that can be done by using your path.split, right? And you can take it in a variable such as file path or file name, right? So in file path your directory structure will come and in file name your file name will come, right? So let us try to do, we have myfile.txt, right? So in this current, when I try to print current dir, so what it will do is it will give me your folder till truenik, right? Right. So now I'll do one thing. I'll do file path equal to os dot path dot join, right? Current dir comma, then we have my file dot txt, right? What I'm trying to do is I'm trying to concatenate your current path with your my file dot txt, right? So now I try to print my file path, so it has got my file dot txt, right? Now I wanted to split it, so that can be done by using your split method, right? And here I will give my file path, right? And this is my file path 1 and file name, and when I try to print file path, in file path only until trunic is there, and in file name my file.txt is there, right? So this is how your split function will work, right? So the next function is your split text. So what does split text does? If you further wanted to split your file into foo and .jpg, that could be done by using your split text, right? For example, os dot path dot split text, then in this you specify the file name. I could say file and extension, right? And when I try to print file got it my file, and extension here it is .txt, right? So this is how it works. So you can have your split text, you can have your split, so likewise you could do it. So this join we have already seen, right? We are trying to join the file path and the file name, that could be done, right? And it could be combined also and split it also, and we have the split text method also, right? Now, okay, so now other method we'll see, remove, right? So we wanted to remove our this new, right? So this is your new directory we have made, it is empty, right? In this part we wanted to remove this, so how we can do is by using your remove method, and here we specify your file path. So first of all we'll check what's in our current directory. Current directory is up till trunic, so os dot path dot join, then we'll specify current dir and we'll specify new, right? We say remove file, remove directory, okay? This is the remove directory underscore path, right? If I try to print it again, it is remove directory path, and here we got a new, right? Now I can use os dot remove and then give my remove directory path. It says operation not permitted, so let me check whether I am using the remove. Okay, so remove deletes the file path, okay? It does not remove the directory, so this we need to remember, right? We wanted to use remove dir, remove the directory path, right? So here we will not use remove, we will use remove dir, okay? Then we'll try to list dir. Now you can see that new gets removed, right? And if we wanted to remove, right, your file, so that could be removed by using your myfile.txt, right? So here I can directly pass my file.txt, so it has removed. Either you pass the complete path, right? Either you can pass here, because we are in the same current directory, right? So this also works, right? So my file also got removed, right? So this is how your modules work, right? Okay, so thank you friends, thanks for watching, hope you enjoyed the video. So stay tuned for the next video.